So when you go to verify trig identities, what this means is you are given both sides of the equation. You just got to show how you get from one state to the other. Okay? Now, in general, when you deal with trig functions, that's a problem because sometimes pieces exist and sometimes they don't. Because the problem, if I just look at sine, it's conditional. Sine is going to be equal to 0 only at certain times. Okay? At multiples of pi. What identities allow you to do, and those are all the things in the front of your book, those are identities. They're always true statements no matter what those variable values are, those angle values are. So what those allow you to do is to manipulate the pieces around because they'll always work. Okay, and that's what this looks at when you verify an identity. You verify it's a true statement. Now, the problem is there's no nice, clean steps for this. There's some general terms, general patterns you can follow, but there's no like set things you can do with this. Okay, so if I have like some of these, typically try to work with only one side of the equation. You're going to have both sides, and you could potentially manipulate both at the same time, but it's very easy to go divergent when you do that and go off in two different directions. And it ends up taking 40 steps, what should have taken 3 steps. Okay, look for chances where you can factor, add fractions, square a binomial, or create a monomial denominator. So if you have plus or minus, look for those conjugates. Look for things like that. A lot of the simplification stuff from the first section will help you a lot on this. Okay. Look for opportunities to use those fundamental identities, the ones that were used in the first section. Okay, to be able to swap pieces in and out. Sine and cosine pair well, secant and tangent, cotangent and cosecant because of those Pythagorean identities. If none of that works, same as before, try switching to just everything to sine and cosine. Okay, but that should be a last resort. Most of the time you can do it without that, and it's going to be quicker to do it without that. Switching to sine and cosine is pretty much maximizing the number of steps it's going to take. And always try something. I would add one more to this. The one I always add to this is manipulate the more complicated side. And actually, I didn't even read that. That says it right here. Until I'm off today. Manipulate the more complicated side first. What else? I actually read what they say in the book. Okay. So, obviously, which side's more complicated? The left side. Okay. So look for things that you know. Pythagorean identities, things like that. How can I simplify the left side to turn it into 1? Top is just 1. Sine squared plus cosine squared is 1. What can I do with the denominator? Secant is squared is 1 over cosine squared. Yep. Okay, you need to at least show that. If you just write a 1 on the bottom, it's going to be counted wrong. The problem with these when it comes to this test and quiz especially, they do take a couple days because pretty much as much time as it took you to take the test, it's going to take me about a fourth to a half of that amount of time to grade it because I basically have to redo every problem. Okay? Cosine squared times 1 over cosine squared, those cancel. Left with 1 over 1 equals 1. Okay?
Grade the test on completion.
Probably not. Verify this identity. Which side's more complex? Left. Any ideas? Yeah. Because the denominators are what compared to each other? Conjugates. If I multiply this one times the 1 plus cosine, this one over 1 plus cosine, this one times the 1 minus cosine, over 1 minus cosine. The numerators, I'm going to get 1 plus cosine plus 1 minus cosine. The combined denominator is going to be what? 1 minus cosine squared. And what is 1 minus cosine squared? Sine squared. And on top, what do I end up getting? 2, because the cosine minus cosine will go away. You're left with 2. And since it's 2 over sine squared, that's the same as what? Yeah. 2 over sine squared is going to be the same as 2 times the cosecant. Okay?
Any harder, right?
A little bit. Everybody good on that one, or are there any questions? Okay. Here. Left again. Any ideas? For what? For the left one, secant squared minus 1 is equal to tangent squared x. Sine squared minus 1 is cosine squared. Why would it be negative? All right, it's sine squared plus cosine squared equals 1. So if I subtract the 1, I have to subtract the cosine. So yes, this is negative when I multiply these. From there, what? Tangent squared is going to be sine squared over cosine squared times negative cosine squared. Cosine squareds cancel, and you're left with negative sine squared x. Okay. Honestly, that's all it amounts to. There's nothing weird about it other than the fact that you need to solve the different situations. Any ideas for this one? First off, which side would you define as more complicated? Yeah, I would actually do the left, because subtraction is usually an uglier thing to deal with than multiplication. Not always, but often. So what could I do with the left side? Yeah, I would change cosecant to 1 over sine. So then if I'm going to subtract sine,
Multiply by sine.
multiply what by sine?
The normal sine multiplied by sine over sine.
Multiply by sine over sine. So if I multiply this by sine over sine, that's going to give me 1 minus, or 1 over sine minus sine squared over sine. So when I put that together, and what's 1 minus sine squared? Cosine squared. So I have cosine squared over sine. And here's where you actually want to split up cosine squared. Because cosine squared is cosine times cosine. Exactly. Split it up. And cosine over sine becomes cotangent. And that works. Some of them that actually look like they shouldn't be too bad because there's not much going on, they end up being quite a few steps. Some that look really ugly end up taking a couple steps. It's kind of hard to judge. Questions on that one? Or are we good? Okay, down here. Which side's more complicated? I'd say the right. The left side you just have a plus sign to deal with. The right side you have both division and subtraction. Okay? So, any ideas there? Yeah, I'd probably do the multiply by the conjugate because chances are that'll allow me to get rid of the plus or minus sign that's between them. So then it's going to be 1 plus cosine, 1 plus cosine. When I do that, I'm going to have sine times 1 plus cosine. On the bottom I get what?
1 minus cosine squared.
And 1 minus cosine squared is?
Sine squared.
So sine squared. On top I have sine times 1 plus cosine.
1 sine.
One of the signs cancel. Because it's not adding or subtracting from anything, it's just multiplying. So I can cancel one of the signs. That leaves me with 1 plus cosine over sine on the bottom. What do you mean split that? 1 over sine plus cosine over sine, which gives you cosecant of beta plus cotangent of beta. Questions on that one? Okay. Which side's more complex here? The left side. The right side you have a subtraction, division. On the left side you have addition, division, and squaring. Any ideas? Honestly, there's probably about 4 different ways to do this problem. So, do what? We try multiplying by the conjugate. If I do that, 1 minus secant, 1 minus secant. The bottom, I'm going to get what? One minus secant squared. And 1 minus secant squared is what? It's not tangent. 1 plus tangent squared is equal to secant squared. So yeah, that's going to be equal to negative tangent squared. You see that? So I have 1 minus secant times tangent squared on top over negative tangent squared on the bottom. What cancels? Tangent squareds are gone. The negative is still there though, right? So what's that going to do to the numerator?
It's going to be negative 1 plus secant.
Yeah, it's going to turn into negative 1 plus secant. Then what could I do? Yeah, change secant into 1 over cosine. And I have negative 1 here. Yeah, you can rewrite 1 as cosine over cosine. Plus 1 over cosine. Combine them, like the same denominator, so I can just, and I'm going to reorder them real quick. And no, I'll leave them separate. Negative cosine plus 1 over cosine. And that's going to be equal to 1 minus cosine over cosine. Okay. Questions on that one? It's a puzzle and you're just trying to solve it, is the truth of this section. You have to go through all the steps, and I have to be able to follow what you did, okay? Real quick, try these 3. These are much easier than they look. Anybody see a commonality in all 3?
Cube or larger.
Which side is more complicated for all 3?
Right.
Right. Okay. All 3 of those, take out the greatest common factor, and they end up being 2-step problems. Tomorrow, I am not going to be here.